So what do we have here? We have 4 minus 0 over 1 minus 0, 4 over 1. So our m value is the same as the k value. Your slope and your constant of variation match. And that's the purpose of these problems, is to prove that. That you can look at the equation in C4, or you can do slope formula in C4. You can also look at the graph and see the rise over run. That's what we talked about Friday. If I count rise over run, it's rise 1, 2, 3, 4, and over 1. So all three of those things match. Constant of variation, slope formula, rise over run. Okay, let's do 12. The constant of variation is 2/3. See that? And now I'll do slope formula. The points are 0, 0, and 6, 4. So 0, 0 in the formula will be the x1 and the y1. And 6, 4 will be the x2 and the y2. Now I'll find slope. I got 4 minus 0 over 6 minus 0. So 6 over 4. Now I just got to say that slope should match your k value. What do we have to do to make our numbers match? We found our k to be 2/3. We found our slope formula to be 6 over 4. What do we have to do to make them match? Simplify. Simplify. Reduce your fraction. I'm going to challenge you in this whole assignment just to keep everything in the simplest fraction form. So the top and bottom here both divide by 2. 6 divided by 2 is 3. Oh man, I switched my numbers. Sorry guys, I was distracted. Does everybody have 4 over 6? I switched those. I messed that up. 4 minus 0 is 4. 6 minus 0 is 6. Divide the top and bottom, and you have 2/3, which matches your k value. M and k are the same. Slope and constant of variation are the same. Now, I want to see if rise over run is also 2 over 3. So I'm going to count up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Yes, it works. It's like a point right there. All right, try 14. Write the equation. Looking at the equation, I can see what the constant of variation is. K is 4 over 3. Says find the constant of variation, then find the slope. So now we'll find the slope. The points. -6, -8, and 0, 0. Every single direct variation equation has a point at 0, 0. X1, Y1, X2, Y2. Do the formula. So this is going to be 0 minus -8. do with minus and negative? What did you do, Tony? Yeah. You have minus and negative, you're going to add that. Turn it to a positive. We get 8 over 6. But these numbers are supposed to match. 8 over 6 is the equivalent of 4 over 3. You just need to simplify it. Top and bottom divide by 2. And we prove it. M is 4 over 3, just like K. And now I can count rise over run. 1, 2, 3, 4. 1, 2, 3, point. 1, 2, 3, 4. 1, 2, 3, point. So this is actually exactly what we did bell work Friday, and I'm hoping this is what you did yesterday on 11, 13, and 15. Okay, let's move on now to making graphs. So flip the page. We're going to do 16, 18, 20, and 22. We're going to do the evens. We're going to have 4 little graphs. I'm going to walk around and look for 4 little coordinate planes on your notebook paper. So we'll just take it one at a time. Keeping in mind that your constant of variation is rise over run. Our constant of variation here is 10. So when I do rise over run, I'm going to rise 10 and I'm going to run 1. If there's no fraction, put an invisible 1 underneath your K value. So when you make your X and Y axis, you're going to need to make sure you get at least 10 spots in. Oh, there's a lockdown drill. I forgot. We're going to go up 10 over 1. Right, Damien? I'm going to be looking for this. Yeah, 4 of them. Yeah, we're going to do 4. And as I walk around, I'm going to be looking to see, like, did you do your graph both ways? So all of these graphs, you can start at 0, 0, because all direct variation goes through 0, 0. And then you move the rise over run. So I'm going to start here, and I'm going to count up 10 and go over 1. And so it's a very steep line. Up 10 over 1 is very steep. I don't want just half your graph though. I want to see you match the pattern the other way. So I'm also going to go down 10 over 1. So I have a graph going both right and left. Questions on the first graph? All right, moving on to the next even number. That would be number 18. Y equals X. You start at 0, 0. But what's the rise over run in this equation? 1 over 1. So when there isn't a number like this, write the 1 in. There's an invisible 1 here. So we're going to rise 1, run 1. So this line should be like significantly less steep. Going up 10 over 1, that's very steep. Going up 1 over 1, that's not very steep. It's actually exactly in the middle. So it started 0, 0. Rise 1, run 1. And I don't want your graph just going one way. Match the pattern the opposite way. All right, 20. 20, you're going to rise, run, and run 6. That should be like very flat. Now we're going to have a very flat line. Started 0, 0, up 1 over 6. Let me give you some time to catch up. What is this? David, I don't know if you were in here when I filled out your phone.
It's 424.
Oh, okay. Go ahead.
I remember.
Oh, you know how to do it? Awesome. Glad you told me that.
I've already shoot. If you got it, I can do it.
Okay. You got to do 22. Did you do 22 yet, Terry?
What?
Did you graph these yet? Start at 0, 0. All direct variation starts at 0, 0. Not all straight lines do, but direct variation does. Count up 1 over 6. Match the pattern the other one. The other way, down 1 over 6. Oh, come on. That's all I got today. So if you look at your lines, they go from steep to middle to flat. Steep to middle to more flat like. Just let them go. Alright, last one, 22. Is this one going to be more like steep, more like middle, or more like flat?
Oh, that's going to be steep.
Up 5 and over 6. Which one's it going to look like? 16, 18, or 20?
Oh, no, it looks like 18.
How do you know that?
What do you mean how I know that?
How do you know that? You're right, 18 is the right answer.
I go up 5 and go over 6. This one looks like 18. I did it.
Start at 0, 0. And that's because 5 over 6 is very close to 6 over 6, which would be 1. Like this fraction is really close to just being 1.
So if it's 1, how would you graph that? Put 1.
No, this was 1.
Oh, yeah.
Up 1 over 1, up 1 over 1, up 1 over 1. Alright, so that's graphing. I'm just gonna look around and see if everyone's had time to get 4 graphs in. If a lot of people are still working. Okay. The last 2 problems are the most difficult. Okay, I'm just walking around it. This and this and this.
Yeah. We didn't want that. We think I'm gonna wear my shirt like this for my I have yeah, there's a I hope there's nothing that important in there. I do too.
And that's actually what we're doing right now. You fill that in, but we're going to finish it in class. You don't have to do anything at home.
I miss.
All right, let's start on 24. So we did these problems on Friday. So if you did them yesterday, like you were supposed to, you had to look at your notes from Friday. These are 2-part problems. Can you do one that says when x equals 16? Well, this one is going to be. Oh, I'll do 26. First, I'm going to do 24. All right, so this is a 2-part problem. It says, suppose y varies directly as x. My tablet pen. See in the back. All right, so as soon as I read this, suppose y varies directly as x. As soon as I read that, I write this down. Y equals k times x. It'd be great if they just gave you the formula, but they don't. It says, write a direct variation equation. You use the first 2 numbers for part 1, writing the equation. Two-part problem. In order to write the equation, you must know k. K is the important number. We don't know. We must find k. That's the work, is finding the k. So we're going to plug in the y and the x to find k. It says y is 6. We don't know k. X is 10. Solve for k. So put your line in. Opposite of multiplies. No, we're going to divide. So I want to challenge you guys, like, if you think about the first problems we did, none of them had decimals. They had fractions. Fractions are good for graphing rise over run. So we're actually, I want to challenge you to leave this in fraction form. Do a lot of fraction work right now. But it should be in simplest fraction form. So how do we reduce 6 over 10? 3 over 5. So we found k in simplest form to be 3/5. So our equation is y equals 3/5 x. And we could graph that. It would be up 3 over 5, rise over run. So this is the relationship that's true if those numbers vary directly. When x is 10, apparently 3/5 of 10 would give us 6. That's part 1, right? The equation. Some students get by with skipping part 1, but I won't give you full credit if you skip writing the equation. Part 2, solve. Says write the equation and then solve. So part 2 is to actually use the equation that you just wrote. So it's y equals 3/5 x. Part 2 says find x when y is 18. I'm going to put an 18 in here. And we have to find x. I think it is 3, yeah. Let's look. I'm going to put the line in. I have to get x alone. What do?
I know you time because you divide.
How do we get rid of that 3/5? You want to divide. That's what we would normally do, but we don't like to divide by fractions. What do? Multiply by the reciprocal. When you're trying to cancel a fraction out, the best move is to multiply by the reciprocal. So I'm going to do 5 over 3 here and 5 over 3 here. And the reciprocal has a canceling effect. So those are canceled. And our x is alone, which is what we were trying to do. And now we just have to do 5 over 3 times 18. Well, you could reduce that. You can use a calculator, you can multiply on your own. 18 times 5, well that's 90. 5 times 10 is 50. 5 times 8 is 40. So 50 and 40 make 90. 5 times 18 is 90. 3 times 1 is 3. 90 over 3. 90 divided by 3, 30. The answer to part 2 is 30. Oh, did you say 3 or 30? So you were pretty close. Alright, so we're going to try that again, keeping everything as a fraction. If you want to do it as a decimal, I will give you credit, just not 100%. Last question. And then I'm going to check yesterday's homework and today's homework. Yesterday's classwork, today's classwork. Yeah. Alright, part 1, write the equation. It sure does. It's all fractions. I don't really like 4 and 1/4. That's called a mixed number. I'd rather have an improper fraction. So let's start by converting that. 4 and 1/4, right? So to convert it, I do 4 times 4 is 16. Add 1 is 17. So I'm just going to do these two first. And then after I'm going to do that. I'm going to focus on these two first. So if it's y equals k times x, y is 17 over 4 equals k times 3 over 4. Emma, in this one, how do you get k along? Yeah, but we don't actually divide fractions. Instead, we multiply by the reciprocal. So I'm going to multiply 4 over 3 here. And that has a canceling effect. So that's going to cancel this out. Which is what I was hoping to do. Now k is alone. I'm solving for k. 40 plus 28 is 68. Yep. 3 times 4 is 12. Then we got to reduce it. Let's just start by dividing top and bottom by 2. They're both even, so we know divide by 2. So 68 would be 34, 12 would be 6. Looks like it can reduce again by 2. So we could have multiplied by, or could have divided by 4, but I did 2 twice instead. Sometimes you do that. So I'm glad we're not graphing this. We have to go up 17 and over 3.
Even if we did anything as a fraction,
As a decimal?
Yeah. So it'd be like
15.6. I mean 5.6. Is that your right? That's 5.6. Alright, part 2, solve.
That's only part 1.
Yeah, writing the equation. Now it says write the equation, done. Now we're going to use this bit. Now find y when x is 4.5. 4.5, I'm going to convert from a mixed number to an improper. 4 times 2 is 8 plus 1 is 9. So that's the same as 9 over 2. So I'm going to say y is 17 over 3 times 9 over 2. That's 153 over 6, which is, they both divide by 3.
They both divide by 10.
3. That's your answer. Okay, I'm gonna walk around and give you credit for yesterday's work and today's work.
Well, I found it.
And you don't got this 25 anymore.
No, no, no.